I'm very pleased to introduce today Professor Nicholas Kristin. He is the Associate Director of the Information Networking Institute. Nicholas received his PhD at the University of Virginia, after which he spent 1 year at Berkeley as a postdoctoral fellow in the School of Information Systems, after which he joined us, not for long. He departed for Japan for about 3 years, and then finally he decided to return to Scilab Pittsburgh. And Nicholas has been doing a lot of interesting research at the boundary between security and policy. And today he will be speaking about search engine manipulation campaigns. Nicholas.
Thank you very much. Thank you very much, Virgil, for the introduction. I'm pleased to see that we have a good crowd today, so I guess that a lot of people are interested in learning how to purchase illicit online drugs. What I'm going to talk about in the next hour or so is research that we've been doing with my student, Nectarios Leontiadis, who is sitting here in the back, and you can ask him difficult questions at the end. And Tyler Moore, who is a visiting faculty at Wellesley College right now. What we've been doing essentially over the past 18 months or so is trying to understand how miscreants, how bad guys make money on the internet. And one thing that we've noticed is that they like abusing search engines. And we're going to see what they do and why do they like to abuse search engines in this talk. Which all stems from one very simple research question. How do you model the behavior of an attacker? So if you're a security engineer, you're used to the typical attacker model where the attacker is omnipotent. They have control over your network. They have control over everything, really. And that's the right way to view an attacker if you're going to devise an engineering solution. For instance, if you're going to devise a crypto system, you want to make sure that you're making no assumptions, essentially, as to the capabilities of the attacker. However, when you're looking at possible interventions in the public policy realm or possible countermeasures at the system level as opposed to at an individual computer's level, that assumption may prove a little bit too strong in that it may rule out certain solutions that could be actually very useful. And one thing that has become increasingly clear since the early 2000s is that most attackers, not all, but most attackers are financially motivated. People are into the business of sending phishing emails, spending spam email, starting illicit gambling sites, setting fake Rolexes because they make money doing so. How much money do they make? How do they operate? What is the supply chain behind all of this trade? We have very little knowledge about it. So the work that I'm presenting today and that we've been doing with my research group inscribes itself into something that we could somewhat pompously call security econometrics. Essentially, we want to come up with economic models of how attackers operate, but to be able to do so, we first need to get a lot of data from the network. I'll just add a note to say that modeling defenders, modeling users, is equally interesting. It's very different, though. One thing that users are not, that attackers are, is perfectly rational. Attackers are very, very rational, which is good. It helps us model them. Users are not, and that yields another field called behavioral security economics, which I'm not going to talk about today. We are not the only people to try to measure how cybercrime affects our lives. And in fact, a lot of this research stems from this paper right here at the bottom, which was co-authored by two people here, Jason Franklin and Adrian Perig, in collaboration with people at Berkeley and San Diego. So if you want to measure cybercrime, there's essentially three things that you can do. You can passively monitoring advertised commodities, meaning you go on a website or you go into an IRC chat room and you just observe what is taking place. And that's what that research from Jason Franklin and some others have been doing. Now, there's a slight problem with that, which is that you're just measuring advertised commodities. You're not actually observing the transactions. You see somebody telling you, I'll sell you this credit card for $3, but you don't know if when the transaction is realized, the buyer will have indeed paid $3. It's kind of like trying to estimate the value of a real estate market just by looking at the prices at which houses are for sale. Well, if you do that, then you may slightly overestimate the actual value of the market. But those works were very influential. I mean, don't get me wrong. They started it. They did. They really provided us with a tremendous amount of information. But in order to have more precise estimates, what some people have been doing is, okay, well, if we want to really know how much those things go for, we actually have to participate in the transactions, either by facilitating the transaction, by providing the infrastructure, or by actually buying some of that stuff. So there are two techniques that have been, two groups of papers in that respect. People have been infiltrating botnets, and botnets are useful to infiltrate because people use IRC servers hosted on those bots. They use payment processing sites hosted on those bots. And so if you have control over the bot, well, you can see actual transactions taking place. That's one strand of research. Another strand of research has been by people who actually went ahead and bought some drugs online. And there's been a few papers coming this year at Oakland Security and Privacy and at Usenix that described this line of research, mostly carried out by our friends at San Diego and UC Berkeley. Yet a third thing that you can do is try to measure side effects of the attacks or external factors from the attacks taking place. Roughly speaking, I would say that what you're going to do is you're going to mine publicly available data. And that's where our work, the work that I'm presenting today, inscribes itself. Specifically, we do not participate into any transaction, but we are measuring the effects of those attacks. And from those effects, we try to reverse engineer the attacks that have been taking place. If you will, it's a little bit akin to saying, well, we're going to measure the pollution levels of a given city and how it varies. And then from that, we'll try to estimate how many cars are driving every day in the city and how many factories are being set up. So it's a method of indirect measurement, if you will. I'm going to talk about two papers that we published in the past year, in fact, in the past 6 months, focusing on search engine manipulation. So the first thing that I'm going to talk about is a new kind of attack called search redirection attacks that actually prompted a very recent change in how Google handles traffic and its applications to the illicit online prescription drug trade. That was published at Usenix. The second talk that I'm going to, the second paper that I'm going to present is very recent work that came out about 3 weeks ago at CCS about exploitation of trending terms. And I will define what a trending term is. So let's first look at drugs. Well, actually, let me take a step back. Why is search engine manipulation, why is search engine poisoning important? So among those studies that I showed you earlier, one of the key results that came out of them, which is not overly surprising, is that spam does not work. If you are a bad guy and you're trying to make a profit on the internet, spam is probably not your weapon of choice. The reason is you realize about one purchase for every 10 million emails that you send. And so a common fallacy is to say, well, it doesn't matter because sending email is free. It's free to send 1 or 2 emails. It's not free to send 10 million emails. You need to have a fairly large infrastructure to be able to do that. You need to purchase bots on a botnet. You need to purchase spamming lists. You have, significant startup costs. So if this is only going to bring you 1 purchase every 10 million emails that you have to send, I'm not saying that it's not profitable. I'm just saying that if you're an attacker, you probably think that you can do a lot better. Something that has a much better conversion rate is social network spam, where you start to get something in the order of 0.13%, according to a study published last year at CCS. The reason why you get better conversion rates is that if, say, I'm following you on Twitter, and all of a sudden, you recommend that I browse a link. I'm likely to click on it because you're my friend or you're my acquaintance, and I follow you, and I'm interested in what you have to say. So they're essentially piggybacking on social networks to boost their conversion rates a little bit more. So if I click on the link in question, that doesn't mean that I'm going to realize a purchase. But if I ask all of you, how many links have you clicked in Viagra emails, I'm probably going to get a 0 from the entire assistance. How many of you have clicked on a link from somebody they were following in a social network? Pretty sure I'm going to get a lot higher penetration. Therefore, you get more exposure, right, to those sites, which inevitably leads the conversion rate up. But the main problem in both types of attacks is that you do not target users well. You're basically blasting. And it's as if I was telling, who in this room wants to get some Viagra from me? I'm selling Viagra. Who wants it? Probably no one is going to step forward and say, yeah, I need some. If you do, talk to me afterwards. We can take this offline. What you want to do, really, is wait for people to ask for that stuff. So instead, you want to be patiently waiting for somebody to knock on your door and say, can I get some Viagra? Then you're going to realize a lot more sales. Enter search engines. What are search engines for? Query the internet about stuff to find. So if you know that someone is already looking for Viagra and then you somehow manage to place your website as a prominent answer to that query, you're going to get, presumably, and I will demonstrate that it is true, much higher conversion rates. You're going to sell a lot more stuff, given the effort that you're putting in. So this is what we want to study. So search redirection attacks. Oops, 1 second. Assume that I want to buy some Cialis. I could actually. So I'm going to go on Google and I'm going to look for Cialis. The problem is that I'm a little bit dodgy. I don't have a prescription for it. So I'm going to Google for no prescription Cialis. And that's the query that I'm sending. And you have to look really quick, but the third link here is from a site at umass.edu. I didn't know that the University of Massachusetts was in the business of selling Cialis, but if you click on the link, you've got a smiling couple. Obviously, they're very happy about their purchase. And that was coming from UMass. So I'm a little bit intrigued, and just to check, I'm going to cut and paste that URL. Are there really some people at UMass selling Cialis? I cut and paste it, I go directly there. And this is the Distributed Systems Research Group at UMass. So what's going on here? Well, I've got a couple of other examples. Allow me to skip them. What is going on is that obviously the UMass site has been compromised. By the way, don't try that example right now. They cleaned up the site and they sent us their malware so that we can examine it. Not after we talked about this on NPR though. So Bob runs a query on Google, for instance, what I just ran, no prescription Cialis, and the results will include some websites that have been compromised, that have been infected. Most of the time, those sites are sites that are running WordPress blogs that haven't been patched, or Joomla, or pretty much any cool interactive web experience you may think of that is not fully patched. When you click on the result, that's going to trigger injected code on the web server side, which is going to realize whether you're coming from Google with specific query terms, such as no prescription Viagra, no prescription Cialis, or if you're coming directly to that website, or if you're coming from Google but for something completely unrelated. Based on the result of that analysis, either it's going to send you directly to a pharmacy website, or it's not going to do anything and it's going to send you to the original site. And that's why we had two different behaviors, depending on whether I came from Google or I directly visited the website. So we wanted to measure the amount of traffic that is taking place in this manner. And so what we did is, well, let's have fun and abuse Google for a year. Every day we ran 218 drug-related queries between April of 2010 and October for the first corpus of data. Then we ran an additional corpus between January and February of 2011. For each of those queries, we collected the top results from Google, and then we essentially followed the redirection chains. Redirection chain being, you click on this link, you go first to UMass, but then you don't even see UMass, you end up at menshealth.com or whatever. These are some of the 218 queries that we used. As you can see, some of them are clearly very dodgy. If you're looking for Vicodin, no prescription, no wonder you're going to end up in the seedy underbelly of the internet. But if you're looking for Prozac side effects, you would think that you're going to get legitimate health resources to try to help you. You don't. On this slide, I present you a large number of results. So let's distill it to the essentials. We noticed over the 9 months that we measured this, that about 74,000 websites were infected with malware, essentially redirecting to those pharmacies. That's, incidentally, 53% of all the results being returned by those queries. The active, meaning the infections that still work, that haven't been cleaned up. Because remember, when you clean up an infection, you're still in the Google cache for about 2 weeks with the old results. The active search redirections, that's 33%. That's about 1 search result in 3. That's bad. What's even worse is that legitimate pharmacies and legitimate health resources, well, legitimate pharmacies over 9 months, with those queries, we got a grand total of 12 URLs. That's over 9 months. They are completely crowded out. They do not appear in the top results anymore. You may think that it's all well and good if those 12 results appear at the top, if they are the first link. They are not. The attack works essentially regardless of the position in the Google search results. On this graph, what I show you is the percentage of results with classification at a given position as a function of the position. And as you can see, you don't notice any big difference between top results and the 10th result. Sure, it's a little bit harder to poison the top result, but the bad guys still manage to do that in about 15% of the cases. Not to mention the large amount of blog and forum spam that I'm not even talking about in this presentation. It does not slow down. So like I said, we collected data for about, for more than 9 months. In fact, we're still collecting data. There's a gap because we didn't stop data collection, but I haven't put it back with this data here. There's no weird thing going on in the hole in the middle of the graph. But what you see here is that as a function of the date, the number of domains that are hosting those various kind of attacks is evolving significantly. Blog spam is declining. Search redirection attacks, the type of attacks that I just described, they are rising. So it seems like this is where the action is. And in fact, it's so much where the action is that Google about a month ago announced that they will stop sending referrer terms as part of their queries. They didn't correlate it to this type of attack, but this is something that privacy advocates have been trying to get Google to do for the past at least 5 or 6 years. And it's only since last year that those attacks have started to really appear and that Google has started to really think about it. So this actually is yielding a change in policy in Google. It's a cat and mouse game, right? Even if Google doesn't send me the referrer, I can tell you how to circumvent this. Sorry. The other thing that was quite interesting in the data that we found is that a lot of websites are compromised for a large amount of time. I think that the median is about 60 days. That's 2 months between the time a website is compromised for the first time and the time the compromise is cleaned up. Attackers also particularly like .edu sites. In fact, because I'm on a webcast and I'm in public company, I cannot tell you which sites at Carnegie Mellon, but there are at least 2, possibly 3 websites here that were hosting some of that stuff. Not Scilab, don't worry. Not INI either, but some other parts of the university. The other thing that we wanted to do is to actually try to uncover relationships in search results. So to do this, we're going to build a graph, and that graph is going to be populated as follows. Every time we find a domain in our results, we're going to see to what it is redirecting to. So for instance, the hacked university hacked.edu has been compromised and redirects to an intermediary node, attacker.com, which in turn is sending the traffic to freerx.com. So of course, it's a fictitious example. That gives us 3 nodes in the graph that we want to build, linked by 2 edges. And then, for a different redirection chain, you do the same thing. And then perhaps what we're going to be able to observe is that some subcomponents of the graph are connected, which would indicate some form of existing business relationship between those different actors. Well, that was the premise, right? We thought, okay, we're going to build that whole graph, and we're going to have maybe 15 different clusters, not clusters, but connected components, and we're going to be able to say, yeah, that's the 15 people. Guess what happened? This is the graph that we have, and I put it in small because it's not that interesting. What do we observe? There's one big, giant connected component. Everybody is connected to everybody else. So when we saw this, we thought, does that mean there's one guy behind all of this? Actually, it's not clear. Probably not is the answer, because we know from other evidence that there's a large number of online pharmacy affiliate programs, and there's probably 9 or 10 guys that are, there's one guy who is bigger than the others, but shouldn't correspond to 96% of the traffic. So what we observe, though, is that they all have partner relationships. They are using the same people to bring traffic to them. So we wanted to dig down a little bit more on this. And we looked at that giant cluster, and we ran an additional clustering algorithm on that big connected component, which essentially is going to group together nodes that have a lot of connections with other nodes in the same group. And essentially, it breaks down that big, giant connected component into smaller communities, if you will. And we find that there's something like 10 big communities. When we looked manually at those communities, they either corresponded to specific campaigns, for instance, a bunch of sites that were all compromised at the same time, or to specific online pharmacies. So if you know what the GlavMed is one of those, it's Canadian Pharmacies, the official name. They're in one of those clusters. So what we also noticed is that there is quite a lot of concentration in the service providers that the bad guys use to host not just their pharmacies, but also the nodes that are used as intermediaries. There are a few service providers that apparently turn a complete blind eye to what's going on. OVH in my native France is one of those. The last thing we wanted to do for that study was to get an estimate of the conversion rate. So this is going back to what I was introducing the talk with. How much money can you expect to make? How many sales can you expect to realize given a certain amount of traffic? So the conversion rate is defined as the ratio of realized sales divided by the number of visitors. A similar definition for email would be the number of realized sales over the number of emails that you send. So to compute the conversion rate is actually not easy. And in fact, there was a paper just about that, only about that at Usenix this year, because it's tricky. I do not claim that the result that we get is perfectly exact, but I think it's a good order of magnitude. So take it as a back of the envelope estimate, but probably as a fairly reasonable back of the envelope estimate. We know that the number of monthly searches for each query in the corpus is about 52 million. We did that by looking at Google AdWords that give us a traffic estimate. We know that 38% of the collected results for the queries that we launched do redirect to online pharmacies. That's our measurements. So we figure that illicit pharmacy stores receive about 20 million visitors per month based on this analysis. So I'm not talking about email here. I'm only talking about search redirection attacks. So 20 million visitors per month. Now, what we did is that we tried to track down the number of monthly visits to payment websites. So we looked, I actually had my students go ahead and go all the way to the payment site, which usually is very different from the pharmacy site. You get, menshealth.com, and you end up at payforrx.com or whatever. It's a different site. That's where your shopping cart is filled up and where you're asked to give your credit card. So I asked students to actually list all of the payment websites that they could find by manually filling cards. And after probably 2 weeks of trying to purchase Viagra online, we got a fairly exhaustive list of payment sites. Out of those, we looked at the websites dedicated to pharmacy sales, and we estimated them to be about 3/4 of everything that we saw. And we also, because we had the list of payment websites, we could also estimate the number of visitors to the sites using the same technique as described before, looking at essentially Google data. And that gives us the ratio of people who went all the way to the shopping cart divided by the number of people who queried for those terms. It's about 3.2%. Now, is everybody who is filling up a shopping cart going to buy stuff? Probably not. Let's be realistic, it's an upper bound. So there's a fudge factor K in here, which I have no idea what it is because I'm not running a pharmacy myself. But assume that, okay, 1 person in 10 that has went through the trouble of filling up their shopping cart goes all the way to buying the stuff. 1 in 10 seems fairly low, right? I mean, if you're at the screen saying, give us your credit card number, you know what you're doing usually. Well, if you assume that 1 in 10 is doing that, then it goes down to 0.32%. It's still much higher than any of the other methods that we've seen. What is the real number? I don't know. Short of actually hijacking a pharmacy and looking at their transactions, it's going to be a very hard number to get. We do have an idea of the total amount of purchases that online pharmacies are fulfilling every month, thanks to that paper by the San Diego folks at Usenix this year. It's relatively consistent with what we see. They found that by spam email, you don't get that much returns, but that this seems to be, we talked to them after the fact, and they noticed that this type of attacks definitely is on the rise. If you want to do something about it, what could you do? I'm going to go fairly quickly over this, but in those redirection chains, there's the infected node on the one hand, and there's the pharmacy at the end of the redirection chain. And then in between, there's a bunch of sites that act as redirectors. They don't do anything, they just take traffic from one side and send it to another side. Sounds idiotic, right? Why would we add indirection? The reason is you add indirection for billing purposes. Those nodes are in the middle because they aggregate traffic. They're traffic brokers, essentially. And so if you're a bad guy, you're going to run one of those nodes so that you know which pharmacies are bringing you money and which are not. Which queries bring you traffic and which doesn't. Those nodes are actually surprisingly low number. There's about 10 to 12 redirectors that we noticed playing a very important role. How did we identify them? Well, that's what this graph shows. Remember the graph I was talking about earlier? You plot the out degree in function of the in degree. If you have a very, very large out degree, meaning you're sending to a lot of different destinations, but you're not getting any traffic in, you're a compromised host. If you get a large in degree but zero out degree, that means you're at the other end of the redirection chain. You get traffic from a lot of people, all converging to one point of sale. You're a pharmacy. What if you're in between? Well, that means that you have traffic coming in and going out, and you're a redirector. And the point I'm trying to make is that if we try to take these guys down, we can probably, I wouldn't say we're going to stop the sale of illicit drugs, but that's an intervention policy that probably would work very well. And it's probably a lot easier to do that than trying to go and clean up all of the MIT.edu and UMass.edu of the world, or going after the pharmacies, which is even more complicated. So what did we find in that study of pharmacies? One group of affiliates is dominating the online trade. That's why you have this big, large cluster in the network. This attack is efficient for the attacker. Legitimate results are crowded out. And the conversion rate is actually pretty good if you're an attacker, which explains why we see this more and more. And so we decided to continue this analysis by looking at another possible target of abuse by miscreants, namely trending terms. So what's a trending term? Well, today, these are things that people are searching for on the internet today, on Google. Sandusky, Penn State. Who was searching for that 3 days ago? Probably no one. But because of the scandal that is unfolding at Penn State, this is a hot topic today. The New York City Marathon is also a hot topic today. A year ago, what people were looking for, Fukushima, I guess, well, 6 months ago. Haiti earthquake, last week, Herman Cain. These things are extremely dynamic, right? News travel fast and news topic change very, very quickly. Actually, it's interesting to see that we have the Steelers and the Ravens both in the hot searches. We beat them on this one. Okay, so what happens when you query for this? Well, either you land onto an appropriate site, but very often you land on questionable websites. So quick, can you tell me where the article is in that news website? I'll give you a hint. It's circled in red. Everything else is an ad. There are even some worse websites than this. I mean, there are some which have zero content, only links, and if you want to get out of the site, well, you can, of course, close the browser, but even if you click on, like, return to Google, it doesn't do that. It sends you to an affiliate, which is pretty cool, actually. It's actually not, it's in a gray area. It's not completely illegal. It's probably a violation of many terms of services that you can think of. It's probably not something that is punishable by law, but it's very annoying. So that's one type of sites that you get in response to those trending terms, and Google has been fighting them without any mercy. Those are called made for AdSense website. AdSense is the Google platform. It's kind of a generalization because they're made essentially for any advertising platform, but because Google's platform is the most, well, is the dominant market share right now, the name MFA comes from there. So if you hear about MFA sites, that's that, essentially, made for ads. If you're really unlucky, this is what you can get. Malware, drive-by downloads. Why? Because it makes money for people to actually run those things. So here you get a beautiful example of a fake antivirus telling you that you've been infected by something in the C document and settings drive. But I'm running Linux, so I somewhat question that pop-up window. And this was on a fake news site, which was essentially cut and pasting stuff from Cleveland.com, from the Sun Sentinel, which is a journal in Phoenix, and so forth. So no content whatsoever, but trying to put malware on your machine. So we were interested in trying to figure out why do people do that, how much money do they make in doing that. And again, we used our collection engine. We collected 9 months of trending queries. Every hour we are collecting 20 Google Trends, and we're checking whether or not they were already present in the set in the previous hour. So for instance, Pittsburgh Steelers from this morning, that was in the set yesterday already. So that wouldn't be a new hot topic. The control set that we're going to use to compare trending terms to regular terms consists of about 500 persistently popular terms. To answer a frequently asked question, yes, Britney Spears and Lindsay Lohan are probably in that set. So there's popular terms that are always being queried. Britney Spears is one example. Barack Obama is another example. Weather is another example. And so we have two sets, right? Terms that are hot but get cold, and terms that are pretty much always hot. Because what we wanted to see is whether or not miscreants are actually focusing their effort on trending stuff as opposed to persistently popular terms. We gathered over 60 million results over these 9 months, coming from Google, coming from Bing. Yahoo and Bing are the same thing now in terms of results because Yahoo is using Bing. We also collected Twitter tweets. I'm not going to spend a lot of time talking about Twitter because we don't have much time, but it was interesting to see that people also target Twitter. So we classify the sites as either MFA, malware distributors, and an overwhelming majority of those, I would say 99%, are fake antivirus type of sites or benign sites. And this, again, is a complicated table that shows everything that we measured left and right. What's important here? Well, first of all, this column tells you the proportion of search terms which have at least one infected site in their results. So for instance, if I Google for, say, let's consider the list of 15, 20 hot terms that I had on the screen before, Steelers, Ravens, Sandusky, Penn State, and so forth, how many of those terms are going to have at least one infected site in them? Well, infected with MFA, 76% of the terms actually have at least one MFA site in them. For Twitter, it's even worse. I mean, it's 94%. So Twitter is actually not doing a good job at policing things. For malware, well, the situation is not as dire, but still, we have about 1 in 5 sites that, I'm sorry, 1 in 5 terms that yield malware. Actually, interestingly enough, for malware, the bad guys have been also fairly good at exploiting the control set of terms. So if you Google for, well, maybe not Britney Spears, but there was another one of those starlets that was a haven for malware. I don't remember who it was. But anyway, that's something that is commonly done. So you may think, oh, that's pretty bad. I mean, that's really a lot of sites. Also, you don't see a lot of malware on Twitter yet. It's mostly for ads right now. Now, that sounds like a lot, but again, it's among those trending terms, the proportion of terms that yield at least one bad result. If you look at all the results as a whole, how many results are bad? Not that many. We get stuff in the order of 0.01 to 0.08%. But again, take this with a grain of salt. 0.08% is not small. It's small in absolute numbers, but remember, we are dealing with 60 million results, which means there's a lot of pages actually that have that kind of crap. Perhaps more interesting is what happens when you do a given search. So we fixed a given point in time and we said, okay, right now, if we look at all the queries that we're doing, how much malware do we see on the site? Well, for trending terms, we see that there's 4.4% that actually yield bad sites. 2.1% are even worse. They're not even detected by Google Safe Browsing, which means that you get infected, you have no way of defending against it. For control terms, the numbers are much lower. So trending terms do pose a risk. So don't Google for Sandusky today. Wait until next week. Why did we do all of this? Well, we wanted to figure out if it would be a profitable business for us. We are graduate students and professors. We're always trying to make more money. And so we're interested in doing this as a side business. How much could we expect to make? Well, first of all, which terms should we try to compromise? On these graphs, I plot for malware and for MFA results the same thing. I look at the proportion of terms that were compromised, that were used to redirect to compromises, as a function of their ad prices. The ad price is essentially the popularity of the term. It's a proxy for the popularity of the term. So for instance, a very big, a very large ad price would be for a very, very popular term. For instance, weather, that's going to have a fairly large ad price. On the other hand, an ad price that is very low denotes that a term is really unpopular. For instance, the ad price associated to the search query Nicholas Christin is probably in the order of fractions of a penny. Get it while it's still cheap. So, what we noticed on those graphs is the same behavior for both the malware and the MFA results. Miscreants disproportionately target sites that respond to fairly unpopular terms. So trending and unpopular is great. Sandusky, for instance, I haven't run the query and Google has cleaned up a lot since then, and I will go into this in a minute. But a term like Sandusky would have been perfect for these guys, because that's not a term that's highly popular. It's just popular today. And so they can actually poison it very efficiently. So they struggle to compromise more lucrative terms, and they're also economic substitutes. Despite the fact that both types of terms yield the same pattern where we see that they have problems getting the most popular terms, malware really thrives on completely unpopular terms. Whereas MFA, they don't manage quite yet to compromise very, very popular terms, but they are somewhat managing to compromise second-tier type of terms. Whereas malware is really going all the way to obscure terms. The last thing we wanted to do was to estimate, again, like I said before, the profits that those sites are making. So to do so, first of all, you need to estimate the number of visits. And we came up with this model. I mean, it's a big word for what it is. It's basically a very simple equation. The number of visits of a website to a website W in response to a term S at time t, I'm sorry, for period t, is the click-through for a given position in search results times the popularity of the term times the interval, normalized to a month. This 4 divided by 30 times 24 is to convert the results that we get for an hour over a month. I'm sorry, for 4 hours over a month. So let me give you an example. On September 24, 2010 at 5 in the morning, a search for DreamHack 2010 status, I have no idea what this is, forgotten, but it was popular at the time. eWorldPost, the website I showed you earlier, appeared as the third result in Google. So you plug that into that formula. The probability of clicking on the third result in Google, that's given because people have been doing studies of this type of things, and we know, I don't have the probability off the top of my head, but there's a distribution for it which is fairly robust, times the number of visits per month, 70 to 600 according to Google, times this normalizing factor tells us that there's about 44 visits per month to the eWorldPost website in response to that term, if you extrapolate it to a month. That's not a lot, but if you add up all of the sites that we found, you find that for MFAs, there's about 4.3 million visits per month to MFA sites caused by trending terms. For malware, it's a lot less. It's about 50,000 in the trending set. It's 30,000 in the control set, which means that the control set, the persistently popular queries are also a problem, but it's a lot less than MFAs. Now, what profits can be made? Well, how much money do you make from an MFA? It's the number of visits times the probability, essentially, that somebody is going to click on one of those ads that you host on your website. Whereas for malware, if you take the fake antivirus model, it's the number of visits times the probability that someone is going to be exposed, times the probability that they are going to pay, times the price that you're putting on your fake antivirus. And you add that up over everything. And we do this, and we get the following results. For MFA, about $100,000 per month. A lot more visits, but each visit doesn't, I mean, it really makes pennies each time people visit. For malware, a lot higher, because people do actually click on that stuff. But it's harder to compromise sites, and it's harder to actually carry this out. So, very, very different revenue models, same order of magnitude. That's what I want you to take away from this. It's not, the sky is not falling. So be wary also of estimates that tell you that such and such criminal business is $3 billion per month. That's usually completely bogus. We're talking about stuff between $50,000 and $100,000 per month in aggregate. Now, realize this. This is just for trending terms. It's a very, very narrow activity. Still considerable, I think. It's considerable enough that Google actually decided to do something about it. By the way, for MFAs, the revenue that I'm listing here is actually a before tax revenue, where tax is defined as Google taking a 32% cut. So Google makes made about $30,000 per month just from that. So you may think, oh, they are in a bad position because they're making money from this. So why would they want to clean it up? $30,000 per month at Google is nothing, and they have a lot to lose if their reputation is damaged. So in February 2011, they actually deployed a revised version of their PageRank algorithm that tries to weed out as much as possible those useless websites. The details of the algorithm were not public, but the effects were clear and measurable. On this graph, I plot as a function of time the percent of the top 10 results, the percent of the top 10 results that are made for AdSense website. For malware, it didn't have much impact, but for made for AdSense, it did. What we see is that the proportion of sites that appear as results to Google queries decreased significantly. In fact, it decreased by about 44%. Concomitant to that, the proportion of sites appearing on Yahoo and Bing increased by 12% because people realized, okay, Google is fixing it. We can just move our traffic to Bing. So that was actually lucky because we were measuring stuff as they deployed it. And so that's actually for those of you who are interested in measurement research, buy more hard drives. Just let your measurements run. Sometimes you get interesting stuff that happens while you're collecting data. To conclude, I hope I've convinced you that if you're envisaging a career in online crime, search engine manipulation is really where you should focus your attention. Because the revenue prospects are significantly higher than what you would get with spamming. So forget about purchasing a botnet, or if you do purchase a botnet, use it as a web server. There are various illicit uses, and today I focused on pharmaceutical goods, MFA sites, and malware sites. There are others. Recently I was talking with a friend of mine. He was trying to buy boots for his wife. And guess what? There's apparently a bunch of sites that are offering perfect replicas of boots. And they're using this type of techniques. We're starting to get a picture of how profits are made. So, well, how profits are made depends on the type of business that you're looking at. For pharmacies, the business is in advertising. The business is in running those traffic brokers that are in the middle of the network. For MFA sites, it seems to be at this point still a much smaller operation, but you know, people have been doing this for quite a while. What we're going to do in the future, well, we're going to collect more and more measurements because that's really what is driving sound economic models. If we want to have an idea of how much money people make, there's no two ways about it. I mean, we can't just draft up a model and say, this is what the world looks like. We have to look at the network and try to extract from it salient characteristics. One thing that I can say as kind of a meta comment over everything that we've seen is that there is a very, very high concentration in infrastructure that we observe. A lot of bad stuff is hosted essentially on a handful of DNS registrars, on a handful of web service providers. And those are not even necessarily bulletproof hosting companies. I mean, if there were bulletproof hosting companies, I would understand. I would think, okay, these guys are paying good money to be essentially, I mean, they're purchasing protection. But a lot of them are on regular service providers that just don't pay any attention or do not want to pay attention to what is going on. Potentially, one can think that one way of intervening is by concerted action. On the one hand, Google, Yahoo, Bing, and so forth, that are actually part of our critical infrastructure, try to exert some pressure to clean up the search engine results. But that can be useful, but that's kind of a cat and mouse game. You also have to exert pressure at the infrastructural level, meaning if we notice, for instance, that a given DNS registrar in India is providing domain information for 3/4 of those MFA sites, well, maybe we want to look into it and, you know, ask that registrar, do you really check who you're sending that stuff to? So with that, I'm going to conclude, and I'm happy to take any questions. Or actually, I'm happy to redirect questions to my student. I can be reached by email, and my office is upstairs. Thank you very much. Yeah. I'll just repeat the question. That's okay.
You said Bing, Yahoo, and Google. Did you look at any other search engines, and did you look at Wikipedia?
No, we didn't. So the question was which search engines we looked at. We looked at Yahoo/Bing, it's the same thing, it's the same API, Google, and we also looked at Twitter for the trending terms. We did not look at Wikipedia, we did not look at YouTube. YouTube would be actually interesting because there's actually quite a bit of stuff going on there, and we haven't yet completely figured out what people do.
Given the importance of computers and the information on them in our society today, do you see it as potentially something that the government should get involved in? Provided, you know, once they get all this information you guys have been providing, should they require either require these search engines to do something about it, or themselves do something about it?
So the question is about the role of government in intervening against those attacks. I don't know, to tell you the truth. One argument can be made that this is a purely economic problem, and adding more regulation to it is not going to solve the problem. It's actually maybe more of a hassle for the search engines. I think that, so I would have agreed with you if I had noticed that Google does absolutely nothing about it, because they are happy to pocket the $30,000 that they make per month out of this. Then I would say, yes, definitely we need government intervention to, you know, coerce them into doing the right thing. But this is not what we observed. We observed that search engines actually try to do the right thing. And the reason is, again, it's an economic proposition. You make $30,000 a month, but the loss in reputation, people start thinking, that search engine is just returning crap. I'm going to switch to Yahoo. That's probably a much more sizable loss for the search engine. And so the economic incentives are actually not, they are not misaligned from the search engine side. Now, in terms of registrars, in terms of people who provide critical infrastructure to those attackers, again, I'm not sure that government intervention is really something that we should be looking at, because it's essentially a borderless problem. If the US government cracks down, say, bulletproof hosting in the States, what are people going to do? They'll move to Mexico. That's what they're going to do. But I think that what we really should be looking at is contract enforcement. Each registrar is given the opportunity to give domain names, to sell domain names to people by ICANN. And ICANN tells them, you have, for instance, to check the identity of the people who register sites with you. You don't have to make it public, but you have to check it. Most sites we looked at don't do that. There's a contract between ICANN and the registrars. Why are those contracts not enforced? That's, I think, so I'm more leaning toward, you know, contract enforcement and essentially economic incentives to solve this kind of problem. Regulation, I'm not so sure it can help.
Are you seeing any action on the side of software security suites like Norton or anything like that in there, green checked browsing sites being able to pick this stuff up yet?
Yeah, so the question is whether or not things like Site Advisor or Norton can actually filter out such sites. The answer is yes. This and Google Safe Browsing, which I talked about, actually do a fairly decent job at filtering out that those sites. However, there is always a lag time, and especially when you're dealing with trending terms, that lag time is being exploited by miscreants. Basically, until the site has been detected as bad, you're vulnerable. And as you can see here, it represents about a quarter of all results. In malware, detected 160,000, not detected 50,000. There's nothing you can do against those sites. They were not in Site Advisor, they were not in Google. They eventually ended up there, but long after the fact. Well, long after the fact. A few hours after the fact, which was enough to drive quite a lot of visits to them. Yeah.
So your trending set, do you know how the malware authors are sort of figuring out what are the trending sets? Are they just copying it off of Google, or are you seeing some independent innovation on the malware side where they might be ahead?
So the question is, how do bad guys exploit, how do they figure out what the hot trends are? We didn't look at it ourselves, but there is a paper at this year's Usenix by a guy named John and co-authors that actually looked at it, and essentially the short answer to your question is that they pick it off of Google. They just, milk off from Google and have something that is essentially periodically they are essentially reproducing the experiment that we have, but instead of measuring stuff, they inject stuff. Okay, well, thank you very much.